So in the last video we saw what the equations you had to learn for logs. So we had to learn that log AB is log A plus log B, and log A over B is log A minus log B, and log x to the n is n log x. They're the three rules. We also have the change of base, that log to base A of B is, draw a fraction line, log on the top, log on the bottom, new base, whatever it is you want it to be, the B goes on the top and the old base goes on the bottom. And so those are the 1, 2, 3, 4 rules that you need to learn for logs. But what we need to do is get used to using them. So you have these questions. You should have at least tried. I mean, they are quite difficult, but some of them, not all of them, but you should have at least tried. If you didn't try and you've just clicked on this video, please pause it now and just try to do some, because you will be able to do some of them, and then at least those ones you can check and the other ones you can see how to do. So, the first three. We'll start off with a nice easy one. Log to base 2 of x is 4. So if we do the opposite of log to base 2, that's 2 to the power of, nice and easy, 2, 4, 8, 16. Easy. Okay, 2, another nice easy one. I think we'll need a calculator though. 5 to the x is 18. We want to do the opposite of 5 to the power of, which is log to base 5. And you can just put this into your calculator. Log to base 5 of 18. Oh, it's, yeah, you do, if you've got the Casio, you do, how did you get that far?
Just log
Isn't it? Oh, that's changing the base to 10.
Right, it's a standard one.
Yeah, log to base 5 is in option, forward, no, hang on, option, forward, no, where is it? Option, calc, forward, that's it. So if you've got the Casio, you do option, calc, which is F4, and then F6, which gets you forward a menu, and then you'll see that it says log AB next to F4. It's a bit of a faff, to be honest, getting there, but that's how you get it. And then what you have to do is press that button, and then log AB, that's that button there, and then you first of all put in it produces a bracket. You first of all put in the base, so in this case a 5, then you use comma, and then you put 18 like that. So it's not very nice to type in, but
and then don't forget to not close brackets, is
yeah.
1.796.
So use your calculator, see if you can make sure you can use your calculator to do log to base 5 of 18 and get that. Okay, the third one. Okay, this is a nicer one to play with. I like the look of this. Quite like log equations. Oh, actually, this looks really fun. Okay, so there's two things I've noticed about this. Firstly, the 8. The 8's going to have to move before I'm able to use that rule. The other thing I've noticed is that the bases don't match. So this is going to be huge, this one. I might give myself a bit more room by getting rid of this lot. Okay, so log to base 4 of x minus 8 log to base x of 4 minus 2 is 0. I'm going to deal with the change of base first. I'm going to change that second base to a 4. So you draw a fraction line, you write log on the top and log on the bottom. Change the base, I'm changing it to 4. The old thing goes on the top and the new thing goes on the bottom. Okay, now log to base 4 of 4 is 1. So that's looking a lot nicer already. Now what I'm going to do is times everything by log to base 4 of x. And it looks messy, but don't forget log to base 4 of x is kind of just similar notation to writing the fourth root. Fourth root is opposite of to the power of 4. Log to base 4 is the opposite of 4 to the power of. So it's not really as messy as it looks. It is just a symbol, log to base 4. And I'm going to times everything by log to base 4 of x. So I will get log to base 4 of x times log to base 4 of x minus 8, and then the 1 over log to base 4 of x cancels with the log to base 4 of x, minus 2 log to the base 4 of x. And this is a quadratic. Log to the base 4 of x squared minus 2 of them minus 8. Now, hopefully I can factorise it. Can I or not?
Yep, you can. Yep. Minus 4.
Log to the base 4 of x, log to the base 4 of x, minus 4 and 2,
Yep.
minus 4 plus 2. There we go. Nice quadratic. So this one gives me log to the base 4 of x is minus 2, and this one gives me log to the base 4 of x is 4. And I can do the opposite of log to the base 4, which is 4 to the power of
Minus 2.
oh, minus 2, thanks. 1 over 16. And x is 4 to the power of 4, which is 64? No.
No.
Yes, 4 of 16. No.
256, yeah.
256.
1, 2,
Yeah, there we go. So that was a nice one because actually I only used one rule, didn't I? I used change of base rule. I didn't use any of the others, but I did use change of base, and I also used the fact that log to the base 4 of 4 is 1. That was the useful fact that I used. And then it's just at this stage here realising that if you times everything by this, then you'll get a nice quadratic, and then noticing that this is a quadratic so it can be factorised. Okay. Right, now this one, number 4, what I'm going to do is use a substitution to help you to see what's going on. If y is 7 to the x, then y squared is 7 to the x squared, which is 7 to the 2x, using GCSE rules of indices. So I can rewrite the equation 7 to the 2x, add 7 to the x of 56, as y squared plus y is 56. Now it's obvious how to solve it. Is that right?
Yeah.
Okay, so y is minus 8 or y is 7. But don't forget, there was no y in this original question. I made that up. I put 7 to the x as y just to help me to solve it. So better go back and actually replace y with 7 to the x. Okay, so the opposite of, well, this first one, this is impossible. You can't do 7 times 7 times 7 times 7 times 7, even if you do roots and get a negative number. So that one's impossible. This one's obvious, I don't even need to use logs. X must be 1. Okay, it's quite a nice one. I'll probably clear that to do the next one to give me some room. So if you haven't been catching up, then pause the video and write it down and make sure you understand. Okay, number 5. Oh, we've got another change of base going on. That's nice. I'm going to change the, well, what shall I, it's up to you. Shall I change the 9 to a 3 or 3 to a 9? What do you fancy?
9 to a 3.
9 to a 3, okay. Yep. So we do a fraction line, write log on the top and log on the bottom, change it to a 3. The x goes on the top, the old base goes on the bottom. Okay. Now log to base 3 of 9, I can do something nice with that. I could write it as log to base 3, instead of 9, 3 squared. Add log to base 3 of x. And then that 2 can come down there.
Yep.
And that will give me 2 log to base 3 of 3. But I know that log to base 3 of 3 is 2. Log to base 3 of 3 is 2. Log to base 3 of 3 is 1. Log to base 10 of 10, log to base a million of a million. It's always 1. So that will just give me 2 there. Add log to base 3 of x is 3. Okay, I'll probably at this stage double everything. Double everything?
Yeah, I think so.
Okay, because I don't really like that fraction there. So 2 of them, 2 of them. This is easy. I've got log to base 3 of x and 2 log to base 3 of x. So I've got 3 log to base 3 of x's altogether is 6. So log to base 3 of x is 2. Opposite of log to base 3 is 3 to the power of, so x is 9. I liked that one. Oh, look, we've got one that's very similar to number 4 now, but looks more complicated. So myself some space here. Sometimes they get quite big, these. Right, now what I'm going to do now is put, here I put y is 7 to the x. I'm going to put y is 3 to the x. So this is obviously y, but I need to think about what these are. So, 9 to the x. Well, if I took y and squared it, then I would get 3 to the x squared, which is 3 to the 2x. That's similar to what I had up here, y squared. Now, I could write that, instead of 3 to the x squared, I could write it as 3 to the 2 to the x, because these just times together and make the same 2x either way round. So this is 9 to the x. So actually 9 to the x is 3 to the 2 to the x, which is the same as 3 to the x to the 2, which are both 3 to the 2x. So all these are the same thing, and this is actually y squared. 3 to the power of x plus 1. Well, I know that x to the a times x to the b is x to the a plus b. So 3 to the x plus 1 must equal 3 to the x times 3 to the 1. 3 is 3, and this is what I'm calling y. So what I've actually got is 3y. So this is actually 3y. So that was a bit tricky, but it's just GCSE. So I've got an equation which says y squared minus 3y minus y, add 3, is 0. Y squared minus 4y, add 3 is 0, which is
-1 -3.
thanks. So y is 1 or y is 3. But same as in question 4, I wasn't actually meant to be finding y, I made y up. And what I was meant to be finding is x, so I need to go back exactly the same as in question 4. So have a flick back through your notes if you can't remember what I'm talking about. And you'll see that the final line looked more like that, because y is 3 to the x. So actually, in both these cases, I can just see what x is going to be. I don't even need to take logs. Okay, 3 to go. You should be pausing the video to sort of catch up and go through slowly and make sure that you're getting the notes for each of the strategies here. Right, number 7. First thing to notice about number 7 is that I need to move this 2. Can't have that there, it's got to move to here. Don't need to change any bases, so I can write it like that. Now I know that log A minus log B is log A over B. Log A minus log B is log A over B, provided the bases match up, which here they do. So I know that I can write this as log to base 3 of x squared over x plus 4. And now I can do the opposite of log to base 3, which is 3 to the power of. And then times both sides, that's 9. Times both sides by x plus 4. Rearrange. And what is it?
12 and 3.
Yeah. So x is 12, or x is minus 3. Nice and easy. Do you want to go to the next one?
I'm going to do the next one.
Let's have a look
Let's see
how much fun you're going to get. Oh, it's a simplified one. It's not an equation. It's just one when you're using the rules to simplify. Yeah. And yeah, I was going to say a little warning, but actually it doesn't apply. But I'll give you the warning anyway, just for future reference. But you don't need it for this one. So, say we had log 4 minus log 3 plus log 2, and we wanted to simplify it. Now, sometimes what students do is they say, well, I like this rule better. Log 3 plus log 2, that's log, and then you times them together, so that's 6. So then they say, right, so this is log 4 minus log 6. And then they say, well, the rule is that you do log 4 over 6. Now, can you see where that's gone wrong?
Yeah, because this minus sign belongs to that log there, and you haven't.
Yes. What we've done is basically put brackets here that aren't really there. So what we've done is, instead of having log 4 minus log 3 plus log 2, what we've done is log 4 minus log 3 plus log 2. Which is completely different because the second one, the minus applies to both of them. So this actually equals log 4 minus log 3 minus log 2. So you do need to be, when you've got 3, that's why I suddenly thought, because there's 3 minuses and pluses, you have to be a bit careful, but in this case actually that doesn't apply, this warning. But for future reference it's a good thing to look out for, just to be careful of. It's something that students do make a mistake with quite a lot. So in this one there isn't an equation, it's just telling you to simplify, and they're all base 10, just to simplify it.
Just to simplify it. Right, okay, so the rules are that log A plus log B is log AB, right? So I could do log base 10 5 plus log base 10 6. Just write the rest of it out. 1/4. So those two I could pull together. Can't
Yeah.
I have log base 10 of 5 times 6, which is 30, minus log base 10 of 1 over 4. Does that mean that that one's already been another negative one? Not that it necessarily matters, but that actually would be log 10 to the 1 minus log 10 to the 4.
Yeah, there's so many ways you can think about this. I mean, what you've said is log 1 over 4 is log 1 minus log 4. Do you remember what log 1 is? It's always 0, exactly. So this is 0 minus log 4. So actually it's negative log 4. But we could have got that another way. We could have said that log of 1 over 4 is log of 4 to the minus 1.
Yeah.
And then the minus 1 can come down the front, minus log 4. So that's actually a slightly quicker way. Or we could just leave it as it is. We could say that log A minus log B is log A over B.
Double deck fraction.
Yeah, it's not very nice, I agree with you. So yeah, I mean, you could now change this to that.
Minus.
Yeah, and then you've got a minus and a minus. So you've got to be a little bit careful with it, but any of those ways is fine.
Right, so we've got log 10, 30 minus log 10 to the 4.
Yeah.
Which is log base 10, 30 plus log 10 to the 4, which is log base 10, 120.
Exactly.
That's as simple as it gets, isn't
Yeah,
it?
yeah, that's as simple as it gets.
There we go.
Exactly. Good, fantastic. Right, so we've got an equation. I like solving long equations.
I'm beginning to like them.
Well, you can do this one and see how much you enjoy it. Do we need to clear any more? Yeah. Oops, gone. Okay.
Right.
So what are you thinking? When you
Well,
look at
first,
number 9?
the bases are the same.
Yeah,
so
the
I don't
bases
worry
are the
about
same, so
changing
that's good.
bases.
Yeah.
Secondly, there's 2 here.
Yeah, and
So
that's
I'm
got
going
to
to move that
yeah,
over.
exactly.
Right, so I might do that first. Log base 3 over 2 minus 3x squared.
Excellent.
Minus log 3 6x squared minus 19x plus 2 0.
Yep. Now we can use the rule.
So log base 3 of 2 minus 3x squared. Is that what you meant?
Log A minus log B is log A over B. Yeah. Does that does sometimes nice things happen when we factorise
I was
quadratic?
going to wonder whether we could factorise it.
But I don't think we can, because I
No.
can't think of anything. It would need to times to 12 and add to 19. And there isn't anything,
No.
is there? No. So we can't. So we'll just leave it. Equals 0? Okay. So now we need to get rid of this log to base 3. So we need the opposite of 3 to the power. No. Told you the answer there. We need the opposite of log to base 3.
Well, it's 3 to the 0
Yeah.
is 2 minus 3x. So this is pretty long. 6x squared minus 19x plus 2.
Yeah.
Well,
You
anything...
do think of it, it's funny, we both think of it the other way round. Because I would sort of think of this being taken away and the opposite appearing here.
Yeah.
So I would have, I mean, obviously it makes no difference, but I would have the 3 to
You
the
see,
0
for
on
me,
the other side.
I'm desperately looking at that going, what do I do with it? And so I'm solving this bit first. I'm thinking, if I'm getting rid of that, then I'm getting that, and what's being left with the rest of it, and what's left of it is that. So, yeah, you're right. But I mean, like you
It's the
said,
same,
it's an
isn't it?
equation, isn't it? So
Yeah.
no matter which way around you're right. So that's 1.
Yeah, anything to the 0 is 1.
So actually, I can just multiply
Yeah.
everything by 6x
Yeah.
squared minus 19x plus 2.
Yeah.
And we're just into algebra, aren't we? 2 minus 3x all squared. So I'm going to have to multiply everything out now.
Yeah.
6x squared minus 19x plus 2, 4 minus 12x plus 9x.
Yeah, 9x squared, good.
Right. 3.
At any stage when you're watching this, you can hit pause, try and finish it off yourself, and then unpause and check.
3x squared plus 7x minus 2 is 0.
Isn't it plus 2?
Plus 2.
So times to 6 and add to 1. No, add to 1. I didn't mean that.
I think it's...
Yeah, that's what I was thinking.
Yeah.
Yeah.
That's equal to 0. So...
Oh, nearly done.
X minus 2.
Excellent. Fantastic. So, which rules did we use there? We used log A minus log B is log A over B.
Yeah.
Oh, and the one everyone likes where you can move the 2.
Yeah, the 2.
Yeah, exactly.
Yeah.
Excellent. That's all of them, isn't it?
That is it.